Hello everybody, this is Mr. Bowman. So today we're going to be looking at the Square Dartboard homework and just making sure that we're setting this up right. So what we got here is a carnival game where you pay $2 for a dart and then you are blindfolded and throw the dart at the board. Okay, and that's what it looks like. So if your dart misses the board completely, it doesn't count, so that's going to make things a little bit easier here. But if you hit one of the yellow squares, you get $4. If it hits the blue, then you lose. Then you don't get anything back. You just lose your $2. So to figure out what's going on here, then they give us the probability of hitting any of these, which is nice and simplified here for us. And we're trying to see, is the game favorable to the player? So really what we need to do before we start is figure out what it means for it to be favorable to the player. So what we mean by that is we're looking for our game to basically something we can make money off of if we keep playing over and over and over again. Okay, are we more likely to win something than as opposed to lose? Which, if it's set up correctly, the carnival probably does not want that to be the case, but we'll see. Every once in a while they mess up. So let's look here. The yellow area is 1/4 of the total area, and the blue area is 3/4. So setting this up, what we can do is say that if I throw randomly, I have a 25% or 1 out of 4 chance of hitting yellow and 3 out of 4 of hitting blue. And what's the outcome of that event? So I win $4 and I have a 25% or 1/4 chance of that happening. So if I keep throwing over and over and over again, say 100 times, I'm likely to hit this about 25 times. So I can multiply those together to figure out what I'd win just off of that. Then if I add that to what happens, my other chance, which I'm going to bring in the losing your $2, that we're going to do that at the end. So let's think about how much we're winning here so we can keep in one mindset. So if you hit the blue area, you win nothing, right? And you're going to do that about 75 out of 100 times. So that is the totality of everything that could happen. So this is kind of like a weighted average here. So if I put these together, theoretically I should be able to figure out how much I'm likely to win if I keep playing over and over and over again. So if I do that, 4 times 0.25 is just a 1. And then this is really nice. 0 times anything is 0 right there. So I get a total of 1, which if I interpret this directly, it means if I keep playing over and over and over again, I'm going to average positive 1 or $1. I'm going to keep winning $1. But this seems initially great. But we had to pay $2 to play, right? So this is what I would expect to win, right? Is my $1. But since I have to pay $2, my net profit, move my camera down a little bit here, sorry. My net profit is actually negative $1. I'm losing $1 on average the more I play. Sorry, I'm losing $1 on average each time I play. So if I'm decide to play this game 200 times, I'm going to lose about $200. Okay, I'm going to win 25% of the time and actually get back quite a bit of money, but I'm going to spend so much playing it that I'm actually going to come out behind. So this is not favorable because I'm going to end up behind. If they didn't charge me to play this, I would win $1 on average each time I played. So that would be fantastic. But since they're charging us the $2 here, it actually comes out behind, which is no good.